Alright, so the very last section that we're going to look at are the partial sums. Okay, partial sums of both the arithmetic and the geometric series. We've already discussed both of those. So if you still need help with those, go back and watch those lessons. But now, instead of just adding up the first 6 terms or adding up the first 7 terms, we want to be able to deal with stuff when it asks for like the sum of the first 50 terms. Okay, or the sum of the first 30 terms. Well, I'm not going to sit here and add 30 terms up like we did in the last one where they asked for like 3 terms or 4 terms. Okay, so whenever we're asked to do large number of a sum of a large portion of it, we can use these formulas. So one is for arithmetic, and we'll do the geometric in a little while. So if you have an arithmetic sequence, okay, then I can find the partial sum. Remember, this means partial sum of however many terms there are. I put my n in there. Using this formula. So for example, use the partial sum formula, so they tell me specifically to use the formula. Okay, if they don't say use the formula, then I can choose. I can either use formula, which will be given to you on your test, or I can just add the numbers up. Okay, so use the sum formula to find the sum of the first 6 terms of the arithmetic sequence 2, 5, 8, 11, 14, and 17. So they've listed out your first 6 terms for you, which is really nice. Again, if they didn't say use formula, I could literally add 2 plus 5 plus 8 plus 11 plus 14 plus 17 and get my answer for the sum of the first 6 terms. But they're wanting us to practice using the formula, so that's what we're going to do. Okay, because again, when it's 6 terms, that's fine. I can add them up. But if it's 50 terms, I'm not going to sit here and add 50 terms up. That doesn't sound like fun to me, and I don't imagine it does to you either. So we use the formula. Here we go. So if I want the 6 terms. First of all, my n is my 6. Remember, n always is always related to the term number. So 6 terms, 7 terms, 8 terms, that's your n value. Okay, I also need a1. a1 is just my first term, so it's just the first term listed, so a1 is 2. And the a sub n, well, we're looking for the 6th term, right? Because n is 6, so the a sub 6. We want the 6th term. Well, what is the 6th term? Well, this is first, second, third, fourth, fifth, sixth. So the 6th term is just 17. Okay, so I have my n, my a1, and my a sub s values. You just plug them into your formula. So the sum of the first 6 terms, that's what that says, the sum of the first 6 terms, so 1, 2, 3, 4, 5, and 6 terms. Okay, so the sum of the first 6 terms is 6 over 2 times a1 is 2, and a sub n is 17. Add those together. So I get 3 times 19, which is just 57. Okay, so when you add 2 plus 5 plus 8 plus 11 plus 14 plus 17, you should get 57, and you do. Okay, so that's all there really is to this first little section. Okay, there's an on your own. Hit pause, try it, come back, see if you can get the same answer. Alright, so here, use the partial sum formula. So they told me to use the formula. They want me to find the sum of the first 5 terms this time. Okay, so I'm looking for 5 terms. It is arithmetic. Okay, that does make a difference because that means I'm going to use the arithmetic formula. Okay, if it's not arithmetic, I'm going to use geometric, and we'll talk about that one in a minute. Okay, so here's my sequence, 2, 9, 16, 23, and 30. So I need the n value. I'm trying to find the 5th term, so n is 5. Okay, I need the first term. First term is just the first one listed. No, it's not always 2. That's just coincidence here. Okay, and then I need my a sub n term, which is going to be whatever my n is, so a sub 5. So I want the 5th term. 1, 2, 3, 4, 5. This is my 5th term, which is 30. Once you're there, you just plug those in. Okay, so the sum of the first 5 terms is 5 over 2 times 2 plus 30. So 5 halves times 32, okay, which is just going to reduce down to 16 times 5, which is 80. Okay, so the sum of the first 5 terms of this sequence, 1, 2, 3, 4, 5, is 80. Okay, and that's all there really is to those. So, example 2 says find the sum of the first 30 positive integers. Now, this is going to be the exact same thing that we just did. We're going to use that formula. The difference here is that you have to be able to recognize what are 30 positive integers. Okay, Positive just means there's not negatives, and integers are your numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Be careful, a lot of people think even integers, which is the 2, 4, 6, 8, 10. Okay, but 2, 4, 6, 8, 10, and if you need to write that down, 2, 4, 6, 8, 10, those would be even integers. Okay, 1, 3, 5, 7, so on and so forth. Those would be your odd integers. Okay, but we just want positive, so just no negative. So these would be 30 positive integers, or just the numbers 1 through 30. Okay, so just the numbers 1 through 30. So 1, 2, 3, 4, dot, 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 all the way up to 30 are your positive integers. Positive. It's only one T in positive. Okay, positive integers. That's what we're looking for. So, knowing that, then I can figure out the rest, because my first term is going to be 1. Okay, I want the first 30 positive integers, so the 30th term is 30, because it's 1 through 30. And my end value is 30, because I'm adding up the first 30 positive integers. So, 30 integers, okay, my A1 is 1, my A sub 30 is 30. Plug all of that wonderful stuff in, so the sum of the first 30 numbers is 30 over 2 times 1 plus 30, okay, which is 15 times 31, which is 465. Okay, so the sum of the first 30 numbers is 465. So if you did 1 plus 2 plus 3 plus 4 plus 5 plus 6, all the way up to 30, you'd get 465. All right, there's that on your own again. Go ahead and hit that pause button. Give it a shot. Shouldn't be too bad. Come back, check your answer with mine. I'm going to keep going. So find the sum of the first 50 positive integers. So I'm still looking at those positive integers, which means A1 is still 1. Okay, now I'm looking at the 50th number, which is 50, because we're going up by 1 each time. And then N is also 50. Plug those in. The sum of the first 50 is 50 over 2. Times 1 plus 50, so you get 25 times 51, which is just going to be, so the sum of the first 50 is 1,275. Okay, and hopefully you got that. The sum of the first 50 numbers is 1,275. Again, you could sit and add all that up, but I wouldn't suggest it. It's going to take a little while, okay, when you can plug it into a formula and have that done in like 10 seconds. Maybe a little more than 10 seconds, but you get the point. Alright, so we're also going to have some nice little word problems, okay? I told you there's going to be word problems in every single section of this thing. Okay, so here's one. So the rolls of carpet are stacked in 20 rows with 3 rolls in the top row, 4 rolls in the next row, and so on for an arithmetic sequence. Now they tell us it's arithmetic. Find the total number of carpet rolls if there are 22 rolls in the bottom. Okay, so you got to be able to pull that information out and know what is what. Okay, so for instance, when I'm talking about my starting value, okay, my starting value is going to be the number in the first row. Okay, 1 is my first row. Well, how many are in my first row? 3. Okay, I also need my last row. So whatever my last row is going to have 22 rolls in it. Okay, so 22 rolls is in that last one. So now I just need my N. Well, N is going to be the row number, because this is first row, this is the last row, so N is the number of rows. Well, it says they're stacked in 20 rows. So 20 total rows is what we're stacked in. So I've got all my values, plug it in. So the sum of the 20 rows there is going to be 20 over 2 times 3 plus 22. Which would be 10 times 25, which is just 250 rolls. So there's 250 rolls stacked inside this, 250 rolls stacked in that set of carpet, or in that, I don't know, stack of carpet, I guess is what it is. 250 rolls of carpet, all stacked up in a pretty little triangle. Alright, so hit pause, try that on your own, although I do want to tell you this. Okay, the 6 blocks, this one doesn't tell you how many rows there are. So you're going to have to figure out how many rows there are from 6 to 15. Okay, so from 6 to 15. That's my hint to you. Okay, I want you to go ahead and try it. See if you can think your way through it. That'll help you when you're starting to problem solve with these on the test. So, see if you can think your way through it first, and then come back and see if you got the right answer. That would be my suggestion. Okay, so now, if you hit pause, which I hope you did, okay, we're looking at pulling out the important information. So the topmost row was comprised of 6 blocks. Okay, and the next row has 7. So again, we're increasing by 1 each time. That makes a difference. And then we're going to look for the total number of blocks needed if there were 15 blocks in the bottom row. So I know my first row is 6, okay, because there's 6 in the first. And I know my last row is 15. Okay, 6 in the first, 15 in the last. We're increasing by 1, so what I have to figure out is what this number is. Okay, how many rows did I go through? Well, the easy way is just to kind of count. Okay, if there's 6 in the first, 7 in the second, okay, that would be 8 in the third, 9 in the fourth, 10 in the fifth, 11 in the sixth, 12 in the seventh, 13 in the eighth, 14 in the ninth, and 15 in the 10th. So to get to 15, I would have to have 10 rows. Now the other way of doing this, okay, is 15 minus 6. Okay, 15 minus 6. Now I know you're thinking, well, that's only 9. Okay, but you got to imagine that I'm counting the 0 row. I'm counting the row that I start on. So the difference between 15 and 6 is 9, and you add 1 to that and you get your 10. Same thing if you go up to this next, the one that we did before. If I would have done 22 minus 3, I'd have had 19, plus the 0 row meaning the one we actually started on, would give me a total of 20 rows. Okay, so that's the difference, because if I start at the first row, I don't ever count the first row, I start on the next one. 1, 2, 3, I would count the difference. So here I want to actually count that first row, so I have to add 1. Okay, so you have 22 minus 3, which is 19, and then add 1 more row. Same thing here, 15 minus 6, and then you're going to add 1. And that's always going to happen because you're going to include the very first row as well. All right, so now that I have all that stuff, I can plug all of that in. So the sum of the first 10 rows is 10 divided by 2, 6 plus 15, which is 5 times 21, which is just 105. Okay, so you have 105, and I forgot my units, that's horrible. Okay, here it's going to be 105 blocks. Okay, so 105 blocks of ice is what I would have to stack from 6 to 15, increasing by 1 each time. Okay? Alright, so that's arithmetic. Now we also have to cover the geometric. Okay, so we have arithmetic, we have to look at geometric. So remember, geometric is the type of sequence where you're multiplying by the same number each time. Okay, so arithmetic is when you like increase by 4 plus 4 plus 4 plus 4 plus 4. Now the geometric is where you're going to have sequences that are doubling, tripling, quadrupling, so times 2, times 2, times 2, times 2. That's the geometric sequence, and when we have that, we're going to use this formula for the partial sums. Okay, so find the sum of the first 5 terms of the geometric sequence 32, 8, 2, 1/2, and 1/8. Okay, so to find that, first I have to know my A1 value. Okay, the first number up there is your A1 value, which is going to just be 32. I also have to know my R value. Well, to find the R, you just have to divide. So 8 divided by 32 is going to give me my R value. Okay, you always go backwards. 8 divided by 32. Because remember, to go forwards on geometric, we multiply. 32 times what gives me 8. So to find that what, you just divide. 8 divided by 32, which reduces to 1/4. And you can check it. 32 times 1/4 is 8. 8 times 1/4 is 2. 2 times 1/4 is 1/2. Okay? So R is going to be 1/4. So just divide the second by the first, or the third by the second, or the fourth by the third. As long as they're right next to each other, that works. Okay, so the common ratio is 1/4. Last thing I need is n. Well, I want 5 terms. If I want 5 terms, then n is my 5. plug that stuff in. So the sum of the first 5 is going to be 32 times 1 minus 1/4 to the n power divided by 1 minus 1/4. Now the reason why I'm putting all these parentheses is because when you go to put this in your calculator, you must use your parentheses properly. These right here are super, super essential. If you do not put your parentheses on bottom, it will be wrong because all you're going to divide by is 1, and then you're going to subtract 1/4 from the whole thing, and that's different. Also up here, make sure you only do 1/4 to the 5th power. That 5 has to be on the 1/4. It can't go out here because then it would be 1 minus 1/4 to the 5th power. That's different. Okay? So when you do that and you plug that into your calculator, you should get, what should you get? You should get 341 over 8. If you got 42 point something something something, just hit that math fraction button and you'll get 341 over 8. Okay, the math fraction button will take you to 341 over 8. So that's where you're at. If you got decimal, I think it's 42 point, I don't remember what the decimal itself actually is, but and it's definitely 42 something. So 341 over 8 would be the fraction. Alright, do the on your own, try it, especially try the calculator. Even if you don't have a calculator at home, do your best to at least try to get that decimal. It should say 42 something. Okay, so give that a shot, come back, hit pause, come back, see if you got the same answer. Here we go. A1 is going to be 5. R is my ratio, so 10 divided by 2 is, or 10 over 5 is 2, so my ratio is 2. Okay, because I'm multiplying by 2 each time. 2, 2, 2, 2, and 2. And then my n value, I want 6 terms this time, so we're going to do 6 there. So the sum of the first 6 terms, okay, and that's important that it's the first 6 terms. We can't skip this right here means the first 6. It's not like the third to the 6th. That doesn't work. Okay, this is the first 6 terms. So we get 5 times 1 minus 2 to the 6th over 1 minus 2. You should get 5 times 1 minus 2 to the 6th should give me negative, let's see, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, so you should get negative 63, 1 minus 64, over negative 1, which should give me a nice positive 315. Okay? Nice positive 315. If you got negative 317, that means you forgot to put your parentheses on bottom. Okay, if you got negative 317, you forgot those parentheses on bottom. So go back, put your parentheses around your denominator, and you should get positive 315. Alright, so now, very last two, in Algebra 3, here's your last 2 examples. I know you're so sad to see it all go. Alright, word problem. Here we go. A grant from an alumnus to a university specified that the university was to receive $800,000 during the first year and 75% of the preceding year's donation during each of the following 5 years. Find the total amount donated during the 6 years. Okay? I want to point this out because a lot of people get confused because it says 5 and then it says 6. That's not a typo. Okay? There was the first year of $800,000 and then 75% for the next 5 years. So you had 1 year and 5 years after that, giving me a total of 6 years. So this is the number I'm using. I want to know the total in 6 years. Starting with 800,000. Okay, and my rate, I'm going to be doing 75% each year, so my rate is going to be multiplied by 0.75 each year. Okay, so 75%, if it was 95, it'd be 0.95. You just move that decimal left twice. Okay, and that's how it's going to work. Anytime you see that percentage, that's going to be your rate. So rate is 0.75. Plug that stuff in. So the sum of the first 6 years will be 800,000 times 1 minus r is 0.075 raised to the 6th power, because that's in my formula. Okay, that n all over 1 minus 0.75. Again, you must have parentheses on bottom or this will not work properly. And you should get 2,630,468 and 75 cents. Don't forget my 75 cents. That could be an extra test tube or something like that. All right. On your own, hit pause. Go try it. Last one. Last time. Here we go. So a new youth center is being established in a downtown urban area. I can't say this word ever, and I'm going to destroy it. Philanthropic, I still messed it up. Philanthropic charity has agreed to help it get off the ground. The charity has pledged to donate $250,000 in the first year, with 80% of the preceding year's donation for each of the following 6 years. Find the total amount donated during these 7 years. What's going to kill most people is they're going to plug that 6 in there. Read these things carefully. Remember I told you at the very beginning, read carefully in this entire unit. All right, so we're starting with $250,000. That's an awfully good pledge. Okay, 80% of the preceding year's donation. So our rate is 0.80 or just 0.8. Those are the same thing. And my time here is 7 years. Plug that stuff in. So the sum of the first 7 years is 250,000 times 1 minus 0.8 to the 7th power over 1 minus 0.8. Plug that in, and you get $987,856 in 7 years. Very nice donation. Okay, so that's what you should be looking at. Again, most of this is just making sure you get it in the calculator correctly. If you can't get it, come to me. I will help you. I will show you how to put it in the calculator correctly. The biggest part is making sure that denominator is in parentheses. That usually fixes most problems. And that is the end of sequences and series, as well as the end of Algebra 3. Very, very nice.